Today I'm going to teach you the systems of linear equation and the different ways you can apply it and solve it. The three ways I'm going to be using is subtraction, elimination / addition, and graphing. And I'm going to be using a interest of mine to give y'all an example of what I am talking about. So this is the problem. Jocelyn went on 2 trips to buy some fabric and spools of thread. On her first trip, she purchased 3 yards of fabric and 2 spools of thread for $46. On her second trip, she bought 2 yards of thread and 2 yards of fabric and 5 spools of thread for $49. What is the cost of 1 yard of fabric and 1 spool of thread? So we are going to be looking for the cost of 1 yard of fabric and 1 spool of thread. Okay, so the first way we are going to solve is going to be with the subtraction method. So we're going to start with that. So these will be the equations I came up with. It's going to be 3x plus 2y equals 46. And this is the first trip. The second trip is going to be let me do this. So x is going to equal the cost of 1 yard of fabric, and then y is going to equal the cost of 1/3 spool. So those are the x and y's. So yeah, for the second trip it was 2x plus 5y equals 49. That's for the cost after both trips. Okay, so first we are going to so I'm going to be using the first equation or first trip. So 3x plus 2y equals 46. We are going to subtract the 3x on both sides because we want to isolate the 2y, or the y, I guess. And then once we get that, we get 2y equals 46 minus 3x since it moved. And now since we want to isolate the y, we're going to divide 2 on both sides. This is going to cancel out, and then y and 46 divided by 2 is going to be 23. And then we are going to end up with the fraction. So negative, or it's going to be y equals 23 minus 3 halves. And then since we got that, we are now going to solve for y since we have the y now, we are going to insert it with the second equation, I guess. So 2x plus 5, not y, but 23 minus 3 halves, and then equals 49. So we're going to distribute this before we do anything, and this is going to be 115 minus 15 halves, and then we are going to 2x, move that down with the 49, and we are then going to convert the 2x into 4 halves, so we can then combine the 15 halves, or 15 over 2 with it. Oh, okay. And then after that, and then we combine it and we get 11, or negative 11 halves, and then plus 115, let me stop doing that, and then equals 49. So we are then going to subtract 115 from both sides because we want to isolate the x, because that was our next step that I forgot to mention. This cancels out, and then this ends up being and then after we subtract that, it's going to be negative 66. And then once we do that, we are going to multiply from both sides. So multiply or negative 11 halves on both sides. And then once we do that, they cancel out. X equals 12. We need to find the y now because we found the y here, but that's not, we need to find, the answer. Yeah. So after x, we are going to use this y and go up here. So y equals 23 minus 3 halves, and then this is going to be 12. So once we we are then going to find the greatest something factor, the factor. Okay, so then these are gonna cancel out, and then it will convert into 3 times 6. Then this equals 18, 23. 18 equals 5. So y equals 5, and these is going to be our answer, our actual answer, and that's how you solve the subtraction method. So yeah, basically to summarize, we are going to start with this. I started with the first equation, since it doesn't matter which equation you start with, because you will eventually need to find both. And then I subtracted 3x from both sides, since we were going to isolate the y. Once we isolated the y, we we used the second equation and inserted the y with this equation that we found first. And then once we solved that and isolated the x, we got x equals 12. And then we used this y equation that we found to then use our x that we found and got our real y. Yep. Okay. Next we are going to use the elimination method. Right? Yep. And we're going to be using the same system of linear equation. To do this, to start, we are going to start off with multiplying the first equation by 2. So 2 multiplied by 3x plus 2y. And then we're also gonna multiply what we got here, the total, by 2. And then for this bottom equation, we're gonna do 2 times 2x plus 5y, and equals 3 times 49. So we're now going to distribute these each on their own to their own, and yeah, so for the first equation, 2 times 3 is 6x plus 4y equals 92. And then for the second equation, 3 times 2 equals 6x again, plus 15y equals 90. Oh, not 92. 147. Okay, so we're then going to subtract these two, and 6x cancels out, so let's leave it alone. 4 minus 15 equals 11y, and then 92 minus 147 equals 55. Yeah. Okay, and then we're going to divide this on both sides so we can isolate y, and y equals 5. Yay. Okay, so that one was pretty easy. And then to find, so this is gonna be our y. Okay, and then to find the x, we're going to use the first equation again, because that is, it doesn't matter which equation you use, as long as like you insert it where it's supposed to go. I forgot. I know it's not called insert. It's called something else, but I forgot. Okay, and then okay, so 3x plus 2, and this is where you insert the 5. 5 equals 46. And then you multiply that, so this is 10 plus 3x equals 46. You're going to subtract the 10 because you want to isolate the x, because we want to find the x. And this is going to cancel out. You get 36 from this, so 3x. You're going to divide this, and x equals 36 divided by 3 equals 12, and that is going to be your answer for the that's going to be your answer for the elimination process. So once again, because I kind of messed up, we are going to be using the same problem. We are going to start by multiplying, because you don't want to, so the reason why we are multiplying is because you don't want to okay, and the reason you want to or if it's necessary, you multiply both equations by a non-zero number so that the coefficients of a chosen variable in the system are opposites. And that's what you do. So yeah, that's why you multiply. And so I chose 2 and 3. So then I distributed to each on their own, and I got these two equations by distributing. And then I subtracted 11. I subtracted these two, and I got 11y equals 55. And then I divided 11 to isolate the y, and we got 5. And then we used our first equation to find the x, and we inserted the y that we found into the equation. And once we did, 2 times 5 is 10, and then we want to isolate x by itself, so to do that we need to subtract 10 on both sides, and 10 cancels out, and then 46 minus 10 equals 36, and to get x by itself we need to divide 3, so 3 divided by 3 cancels out, and then 36 divided by 3 equals 12. So that would be our x. Since, yeah. All right. Okay, now we are going to start with the graphing method. So to do this, I rewrote this here since we're on the back of the page. So for this, I started with the first equation. So I did this. 3x plus 2y equals 46. So, yeah. And then I'm solving for y, so I can find the y-intercept and its slope on the graph. So I need to charge my laptop. Okay, so I started with that. And I want to isolate the y. So we're going to do that by putting the 2y on this side and subtracting 3 on both sides to get negative 3x plus 46. And once you do that, you are going to divide 2 by both sides. So you can isolate this. And then y equals 3 halves x, and then this is going to be 23. Okay, and then this is going to be our y-intercept, this equation. So y equals negative 3 halves plus 23, and then our slope is going to be negative 3 halves. So yeah, and then okay, and then the next equation, 2x plus 5y equals 49. We're going to do the same thing, isolate the 5y, put it on this side, negative 2, minus 2x. We are going to then get negative 2x plus 49. We'll divide 5 on both sides. And then y by itself, we get negative 2 fifths x plus 9.8. And 49 divided by 5 is 9.8. And then we are going to insert this here. Y-intercept is negative 5 plus 9.8. And then slope equals negative 2 fifths. Okay. And once you finish with that, you are going to want to then graph it, so you can make your own graph. For the y-axis, you're going to want it at least to be up to 25. And then for the x, I think like around 13. But I went up to 17 because I had enough space. Okay, so I forgot to mention, but since we found our y-intercept and we found our y-intercepts, we are going to plot our y-intercepts on the graph. So 23 is going to be up here on this line since it's at 0, and then for equation 2, we are going to be at 9.8. So like, okay, my phone died, but I just realized my mistake. This is on the wrong thing. This is y, so this is going to be 9.8. So this is going to be somewhere right here, and then this slope would be I don't know if I did that. Okay, I'm redoing this. So the slope would be this. So we're going to go right 5 down 2. Okay, so right 5 down 2. So it's gonna be right here, around here. Ignore that was wrong. And then, so if we, and I know my lines aren't gonna be like straight here, so I'm gonna show the points. I'm on the Desmos graphing calculator, and I put in the two linear equations, whatever, and here it says the point is 12.5. 12x 12 y 5, and that is gonna be our point intercept, which is our answer. So once you get the intercept, so yeah, our x is 12 and our y is and our y is 5. So yeah, that is going to be your answer.